Hey Science Fam, today we're going to be looking at questions 5, 6, and 7 for half-life problems, get a better idea of how to do them. So if we look, cobalt-60 has a half-life of 5.3 years. So that means every 5.3 years, half of cobalt-60 is going to be left. Now, if the pellet has been in storage for 26 and a half years and has 14 and a half grams left, how much was present when it was put into storage? So we want to go back in time and figure out 26 and a half years ago, how much cobalt in grams was there? So let's go ahead and do our chart real quick, right? We want the number of half-lives. We also want to pay attention to our mass, and we want to pay attention to, in this case, how many years, all right? So we'll start there with our chart, and then we'll go from there. All right, what do I know first of all? Well, I know that when no half-lives have gone by, no years have gone by. I do know that after one half-life has gone by, that 5.3 years have gone by. Now, if the half-life is every 5.3 years, I can just add up my years by 5.3 until I get to that 26.5. So another 5.3 years would be 10.6. Another 5.3 years would be 15.9. Another 5.3 years would be 21.2. And another 5.3 years would finally get me to 26.5. So that means how many half-lives did I go through? 5.3 was one half-life. 10.6 was 2. 15.9 was 3. 21.2 was 4 half-lives, so that means I went through 5 half-lives. Now, if I remember looking at this, it says that I ended up with 14.5 grams at the end of 26.5 years. So if I want to work backwards to figure out how much I have, we know that every half-life, you divide it in half. Or 50% gets cut. So if we want to go backwards in time, the opposite of dividing in half is multiplying by 2 or doubling it. So I'm going to take 14 and a half and in my calculator multiply it by 2. 14 and a half times 2 is 29. All right, so now that gets me back to after 4 half-lives, what was there. Now I want to know what was there after 3 half-lives. So I got to go back in time one more time. So I'm going to double it. 29 doubled again gets me 58 grams. Now I want to go back in time to see what I got after 2 full half-lives. Well, 58 doubled or multiplied by 2 is 116. Then I want to know after 1 half-life how much was left. Well, 116 times 2 on my calculator is 232. So now I just need to get back to when there was no half-lives, the original starting point. 232 times 2 doubled is 464. So my answer becomes 464 grams is what I started with 26 and a half years ago. Now, if that confuses you going backwards, just remember, when we go through a half-life, whatever you started with, it gets 50% cut after 1 half-life. So does this continue to get cut in half when we go down? And yes, it did. So we just worked backwards and doubled from the end towards the beginning to get to where we were first. But that's our answer. We ended up with 464 grams. All right, nice job. Let's go ahead and move on to question number 6. And to do that, let's start reading to see where we are at. So I've got a 1 kilogram block of phosphorus. All right, so it looks like I have a mass there. Perfect. Let me clean up here. Here we go. So we got 1 kilogram block of phosphorus 32. It has a half-life of 14.3 days and is stored for 101 days. All right, so we know that the length of a half-life is 14.3 days and that it's going to be sitting there for 100.1 days. At the end of this period, the 100.1 days, how much remains? All right, so let's start busting that out. And to do that, let me zoom in just a little bit more to give us some space. And I think we'll be good. So I'm going to do my chart, and I'm going to do my half-life. I'm going to do my mass, and I'm going to do my time, which is in days this time. My last question was in years. This one's going to be in days. All right. Well, let's do it. at 0 half-lives, no days have gone by, and it looks like I started with 1 kilogram of a substance. All right, every 14.3 days, we go through a half-life, and we have to have it sit for 100.1 days. So let's just go ahead and knock those days out. If I keep adding 14.3 days, again and again, another 14.3 is 28.6, another 14.3 is 42.9, another 14.3 days is 57.2, another 14.3 days is 71.5. Whoop, I'm running out of room, so I'll do my side chart over here to continue it. Let's do that. After 71.5 days, another 14.3 days is 85.8 days. And after that, another 14.3 days gives me 100.1 days. All right, so now that I figured that out, let me see how many half-lives that is. So let me get a different color to help here. After 14.3 days, we went through 1 half-life. After 28.6, we went through another. After 42.9, we went through a third. 57.2, we went through a 4th half-life. 71.5, we went through a 5th half-life. 85.8, we went through a 6th. And 100.1 days, this thing went through 7 half-lives. So what does that mean? If it went through 7 half-lives, that means it's been cut in half 7 times, or it's been reduced by 50% 7 different times. So literally we have to take 1 kilogram and we have to divide it by 2, or cut it in half 7 different times. So let's do that. 1 divided by 2 is 0.5. Divided by 2 again, 0.25. Divided by 2 again, 0.125. Divided by 2 again, let's see, that's going to be 0.0625. Divided by 2 again, 0.03125. Wow. Divided in half again, that 0.03125, and again is going to be 15625. 15625. Sorry, I'm running out of room. And then divide it in half one more time. I'll write it down here so it's easier to see. 0.00782125. And that's in kilograms. So is there much left after the 100.1 days? No, not much at all. But we had to use our chart to figure out, all right, how many half-lives did it go through? It went through 7. So that means this thing had to get cut in half. 1, 2, 3, 4, 5, 6, 7 different times. And that's how we figure out what is left. All right, but that completes question number 6. Let's glance at number 7. A sample of air from the basement is collected to test the presence of radon-222. Remember, radon gas is the number 2 cause of lung cancer in the world after smoking. So radon is something you don't want in your basement. All right, but it says that the half-life is 3.8 days. So that means every 3.8 days, 50% of that radon has broken down and turned into something else. However, delays prevent the sample from being tested 7.6 days later. All right, so this radon was sitting around for 7.6 days. The measurements indicate that we have 6.5 micrograms. All right, by the way, that fancy symbol there, mu, is actually a microgram. All right, so that we're talking about very, very small amounts here, but don't let that intimidate you. All right, focus on the 6.5. So how much radon was present when it was first collected? So we know that after 7.6 days, 6.5 micrograms remains. We want to know originally at 0 half-lives, right? At 0 time, the beginning time, how much was actually left. So let's do that. We've got our half-life, we've got our mass, and we've got our time, which in this case is going to be in days, it looks like. Let's draw our chart. First of all, we know after 0 half-lives, no days have passed. Now we know that after 1 half-life, 3.8 days have passed. And we want this thing to sit for 7.6 days, which means it has to go through 1 more. A second half-life, 3.8 plus 3.8 would be 7.6. So now we know that this thing sat through 2 half-lives. And when it did, it was left with 6.5 micrograms. So we want to go back in time to figure out how much we originally had. And we can do that because remember, when you go through half-lives, you just divide by 2, cut it in half, 50% each time. So what's the opposite when you're going backwards? Just double it. So 6.5 times 2, when you double it, is 13 micrograms. And then that would be for how much was left after 1 half-life. Now we want to know how much we originally started with. So 13 doubled times 2 is 26 micrograms. And that's what you ended up with. So at day 0 or time 0, it was 26 micrograms. And then after 7.6 days, only 6.5 micrograms remained. And that's because of half-life. Things naturally decay and break down. But all right, there you go with your last 3 examples for your half-life problems. Hopefully this was a great support system for you, and feel free to ask questions in class. Take care.